Does that work? Okay. Yeah, so a couple years back, I was experimenting with bringing Geth on the Gnosis chain, and this is a summary of this experience, and also I wanted to share some learning from that. Yeah, so differences between the Gnosis chain and mainnet. There's a 5-second block time, which is inherited. So the Gnosis chain used to be a chain called XDAI, which has a token that is a stablecoin. And yeah, the block time was 5 seconds, and the idea behind this whole thing, I think that was before my that was even before I was part of Ethereum, I think, was to get some traffic, to offload some traffic into some kind of side chain, do the transactions without going to like without competing for the main pool on mainnet. That was the time of CryptoKitty, and yeah, they went for a shorter block time, and this has been inherited since, and so we find ourselves with this block time. It's quite interesting for me because, as Tony was saying just before, we want to reduce the slot time. So 5 seconds, 6 seconds, it's not too different. So that's quite an interesting experiment as far as I'm concerned. When you look, and I will go into this later, when you look at the size of the state, you find it to be a lot smaller, which makes sense. It's a side chain that is meant to offload some of the traffic, so it's not going to have the exact same size. What's a consequence of the block time, however, is that the history is, like in terms of block, is about twice as large as what it is on mainnet. It was using this consensus called Aura. I'm not going to get too deep into this, but it came from Parity, and it's effectively a proof of authority consensus algorithm. But they try to make it a bit more decentralized by using some kind of voting DAO thing. So yeah, that's the status. Eventually, they got rid of it. One of the interesting part, or maybe infuriating, depending on how you look at it, it relies a lot on system contracts. So the consensus will call a contract an on-chain contract, so you can tweak the way the consensus is working this way. In terms of history, the forks were a bit different. Some people just decided not to use some EIPs during the fork, so they were activated later because they wanted to look more like mainnet, but the original designers seem to have decided there were some EIPs they didn't want on their chain, so it's a bit of a patchwork of history. And the work has been done by the Gnosis people to try to bring the chain closer to what mainnet is, but yeah, historically it's not quite true. You've got the concept of service transaction, which are transactions, for example, I think it's the bridge that brings some tokens from mainnet into the Gnosis chain. So you need to be able to mint, and you don't pay for this. So that's another interesting difference. Yeah, and then the other difference is that, for example, like the other major difference is that the EL uses a stable coin, which is XDAI, and the CL uses the GNO token. And then, yeah, I added a rant about incompatibility of the block format, but that's a detail. So if you dump the two states, like the Gnosis state and the mainnet state, you see some interesting information. Like, for example, if you look at the code, there's about 10% as much code on the Gnosis chain as the mainnet. But if you look at the accounts, there's about 40 times more accounts on mainnet as there is on Gnosis. That makes sense, right? Once again, it was meant to offload some traffic from the mainnet, so not move everything. But the interesting part is that the storage nodes, however, are about half of mainnet. That means there's a lot more content per account on the Gnosis chain as there is on mainnet. And honestly, that's I mean, I don't have a definitive answer of why that is. It could be that it's mostly designed to do ERC trading or other things, so that would explain why there's a lot more contract. But it seems that there are actually relatively fewer simple XDAI accounts on Gnosis chain. And then you have the account and storage snapshot, which is pretty much the same information. The other interesting part is that the bodies, the number, like the total size of bodies is about 1/3 of what it is on mainnet, but there are way more blocks, and that makes sense because the block time is much smaller, so you have less time to execute. Like if I'm not mistaken, the gas limit, like the target gas limit currently on Gnosis chain is 17 million, so about half of what we want on mainnet, and yeah, so you can see there are more headers, but the blocks themselves are smaller, and yeah, that makes sense. The last interesting thing is the receipt. The size of the receipt on Gnosis chain and mainnet is about the same. And I'm actually quite curious as to find out why that is. I don't know for sure. There's definitely an explanation that I was talking about system contracts before. Those system contracts emit logs. I assume it's related, but it would be a further investigation. It would be interesting to figure out why. Yeah, I don't have a lot of time, so I'm gonna skip this one. But okay, I'm just gonna summarize it very quickly. Let's say when Gnosis recovered that chain from, I think they were called POA networks, it was pretty much, there was a lot of legacy going on. They still had parity. Nethermind was just started, but they didn't have SnapSync. They were not serving SnapSync. They were using a protocol that was about to get discontinued in Geth. Like I said, the Gnosis team has tried to bring the chain, like to modernize the chain, to bring it closer. So they deprecated parity. They removed Aura by doing a merge, and yeah, like Nethermind implemented SnapSync, so things started to look a lot more like mainnet. Yeah. So the first attempt was to try to create something. The first attempt at bringing Geth on this chain was trying to get something like history expiry. And the idea is that you would have Nethermind following the chain, and Nethermind had implemented Aura. I didn't want to. And so the idea is that I would get some kind of bootstrap version of Geth that would just import a dumped state from Nethermind and try to pretend that this was a proper sync. And so the merge would be skipped, the whole Aura history would be skipped, and then this instance would only exist, would be unique, and we would spin up other guest nodes that would snap sync from it. For many reasons, that didn't really work out. One of them is, I had to do a lot of guesswork. It wasn't really clear that some forks were activated and when they were. At least it wasn't clear to me. And yeah, they're still. I came also to the realization that a lot of the Aura stuff still remains behind. So I think at this point it made sense to just re-implement Aura. And Aragon had done it in the meantime. They were brave enough to read the Rust code from Parity. So good on them. And I took it and I adapted it to Geth. So as it turns out, that was the other discovery. Like the code of Aragon has drifted, especially in this part, has drifted significantly from Geth. So there was some adaptation work to do, but it was manageable in the end. And yeah, like this implementation of Aura didn't have to be good enough to run a future Aura network if anybody wants that. It was just meant to be good enough that Geth could full sync up to the merge block and move on and ignore Aura for the rest for the end of times. So full sync, when I did that full sync, it took about a month. I ran into all the peculiarities, so this is when I went from guesswork into actually figuring out what the problem, like block per block. So yeah, like for example, the most famous example is that there's a code limit that was activated at a given fork, like 24 kilobytes. People want to change that to, I think 48 is the last number. But for Gnosis Chain, it was not activated at the same time as mainnet, so they activated it in Shanghai. So this is one of those examples. But now we have Geth on Gnosis mainnet chugging along, and so far it's working fine. I'd say the biggest lesson of this whole story for me is that system contracts are a bad idea. They're all the rage right now, and I think it's a mistake. So that's some controversial take right here. I mean, I could list all the reasons, but the biggest one is that most clients, except Geth at this point, do not trace system contracts. And so if you are trying to develop a client for a chain that whose consensus relies heavily on that, it's really hard to figure out what's going wrong. And it's also harder to debug, like the system contracts are harder to debug because you can't put a breakpoint in the system contract. You have to put a breakpoint at the client level, and somehow you have like a lot of overhead to figure out what the contract is doing. The behavior is pretty opaque, and you probably heard of the Pectra testnet fork debacle. So this is actually the fixed version of the code that caused the debacle to begin with, but they were expecting, like the code was expecting sorry, I'm looking for the word, a message to come from the contract. And because Sepolia is a peculiar chain, they deployed their own, like when I say they, I mean ETH Panda Ops. They deployed their own contract. They didn't really tell anyone how it was working, so no one was expecting this. This is not a dunk on ETH Panda Ops at all. I'm just saying this is bound to happen because to people doing DevOps, it looks like it's just delegated to the execution to the execution layer, like the consensus part is delegated to the execution, and as long as execution works, you should expect it to work. But then the message didn't travel, and therefore like client devs had no idea that this was coming. Some, if I remember, it's Aragon who did it right. But most other clients were just expecting this pattern. They were not expecting a different pattern, and this is how Sepolia got in trouble during the fork. So I think it's pretty clear to me, my opinion, that we should not have system contracts. Everything should be deployed as actual native client code. That's my conclusion from this, at least. Now I'm gonna go over the list of changes that could be interesting for Gnosis Chain. There's the protocol level, and there's what Geth could do. At the protocol level, I think the biggest gain for Gnosis Chain would be EIP 4.4s, namely history expiry. There's a lot of blocks, and all those blocks are almost empty, but together they take a lot of space. They take a lot of space, especially for the sync, because the full sync, you have to go over every one of them, and Geth recomputes the state root at every block. So that's why it takes a long time. You could do something like, for example, Aragon and REST, they do something where they just execute the transactions and they compute the root at the end. We could do something a bit similar in Geth, maybe compute the root every 10 blocks, every 128 blocks. That would be interesting to check, to do. So that could be my next experiment on Gnosis Chain, because once again, that's where the benefit is going to be the greatest. Okay, Tony talked about delayed execution. I also forgot to mention about EPVS. So sorry, POTUS. But the idea is, because the block time is so short, it might be interesting for offering some extra capacity to the chain to implement that on Gnosis Chain as well. So that would be my two favorite topics to implement if I was the one deciding what goes into Gnosis chain. I mentioned the bloatnet, so this is an effort that I work on for the EF. The goal is to really make a fork of any network and try to really increase the size of the state. I think that would be also interesting to probe two things. The first one is for Ethereum mainnet, because we are close to a 6-second slot with a 5-second slot. We could try to use the Gnosis chain, or at least a shadow fork of it, to figure out how the mainnet would react in case the block size, the slot time is reduced. But it's also interesting, once again, to study what capacity is really available to a network with a 5-second block time. Otherwise, yeah, I think Geth, it's pretty clear that Geth needs to be able to enable, to have a better granularity in its capacity to enable, to turn on and off EIPs. So that would be something great if Geth could do this. Yeah, so not really a lot to say, except GC Geth could also bring some things back into Geth. Honestly, yeah, I guess I'll just skip this one. It's not very interesting to most of you. Yeah, last slide. So what is GC Geth today? You can find it at this address. It's more or less synced with Geth Master. I need to rebase it on the last release, but it's not going to be a big problem. It's just one release behind, and it will be fixed this week. It's the interesting part, and what I named this presentation after, is that Geth on this network, on Gnosis, is actually a minority client. And it's quite interesting to look at its behavior, because, for example, when you start Geth, Gnosis chain Geth, it takes forever to find a peer. For some reason, like Nethermind and Aragon nodes are extremely reluctant in accepting a GC Geth connection. So it happens over time, but it takes some time. So I'm not sure why that is, but this is definitely the next thing that needs to be investigated, because it looks like Geth, being on the main chain, being the top client in this in terms of usage, never had this problem, in the sense that it can very easily find a Geth node. Not so on the Gnosis chain, so something to dig. Yeah, and very few people have installed it, from what I can tell. So yeah, if you're running a Gnosis validator, please run GC Geth and tell me if there are problems. And the last thing, the Gnosis chain, I'd say the marketing was they want to be a canary chain to support Ethereum and test some things. And I think recently they delivered this, because Holiski failed, like the Pictra 4 for Holiski failed, the Pictra 4 for Sepolia failed, but the Pictra fork for Shadow, which is the testnet for Gnosis chain, went without a hitch. So yeah, and that includes Geth. I mean, Geth was almost ready then. It managed to go through the fork afterwards. So I was a lot more confident about the Pictra fork on mainnet and on Gnosis chain as well. And it turns out I shouldn't have been. There was a consensus bug that showed up in Geth right after the fork. But it was thanks to Nethermind and Aragon, we fixed it, and it was just a configuration issue. Yeah, that's pretty much it.
Yeah, I think we have time for questions. Okay, one here.
Hi, Guillaume. Thanks.
Hi.
I was just wondering if you have a rough idea of how many nodes are running Geth on Gnosis currently, and perhaps more importantly, how many validators? It's because of a lot of validators are running Nethermind, I think.
Right. I don't know how many exactly. I know of one guy who's running it, so he's the one reporting. No, that's not me. That's not me. I mean, I'm also running it, but another guy who writes me when there's an issue. So that's you. Oh, Luca? Yeah, awesome. I'll give you a hug afterwards. So as far as I know, that's you. And thanks for that. Yeah, I was going to. I talked to the DappNode guys. I'm gonna try to have it released as an option inside DappNode. So since the DappNode has a huge user base in Gnosis chain, I hope more people will be as brave as you. But yeah, so far, as far as I know, it's you.
Someone else?
And sorry for doxing you, by the way.
Oh, yeah.